So here's theorem 2.3, and this is a generalization of what we I think intuitively figured out in those last examples, right? So if we have a situation like this where we have 1 over some binomial with x in it to the nth power. So that's kind of what we had last time, right? 1 over x to the n, or 1 over x squared, excuse me. And so we could have some value a in there. And remember, all this is a horizontal shift, right? So the a would move it left or right in that case. So it'd be the same graph. It would just be moved over to the left or the right, okay? So as x approaches a, what's going to happen is this value, if you have x equal to a, that will give you a 0, right? Like like 3 minus 3 would be 0, right? 5 minus 5 would be 0, etc. And so as you get closer and closer to a, this value is going to get closer and closer to 0, like we saw in the last problems, right? If this is an even integer, then when you apply an even exponent to a number, it always comes out positive, right? And so whether it's negative or positive. And so if you square a negative, you get a positive. If you square a positive, you get a positive, right? And that's the same for any even power exponent. And so no matter what, this will come out positive, right? And if this number gets closer and closer to 0 on the bottom, and you do 1 divided by that, it's going to get larger and larger like we saw before. And so since this is always going to be a positive, smaller and smaller number as we approach a, that means our overall value of this function is going to get larger and larger in a positive way towards positive infinity, right? Okay, so if this is an even integer and you have this type of function, then that'll approach, as x approaches this value, the whole function will approach, or the outputs will approach positive infinity, okay? Now if n is an odd integer, okay, so if this is odd, then it depends on which side you approach from, right? Because if you approach from the positive side, then this will be a positive value, right? Like if x is just a little bit bigger than a, but gets closer and closer to a, then it's going to end up being some really small numbers, but positive numbers, right? And so if you do 1 divided by those really small positive numbers, and they keep getting smaller and smaller towards 0, then you're going to approach positive infinity when you do 1 divided by those numbers, okay? Same thing here. If we approach negative, or if we approach a from the left, these numbers are going to be just a little bit less than a. And so as we get a little bit closer to a but less than a, this is going to be a negative number, right? So this will become a negative, really small number. And so when you do 1 divided by a number that's negative and getting more smaller, closer to 0, then this will be the output will approach negative infinity, okay? All right, so when this is odd, when these exponents are odd, then it depends on what side you're coming from. If you're coming from the positive side, you'll approach positive infinity. If you're coming from the negative side, you'll approach negative infinity, okay? All right. And remember, if you forget about this, like, if you forget this theorem 2.3, this is what it means. Just plug in numbers, right? You can always make a table and kind of figure this out if you forget all of these, theorems and things like that, okay? All right, and let me just show you the graphical representation. And we talked about this with 1 over x and 1 over x squared. I showed you the rough sketch of the graphs. So here, here's what they look like generally, right? So this is, if you have a situation like this, where you have x minus a. Remember I told you x, this minus a is just a horizontal shift. So this moves it right a units. So instead of 0 being, or instead of the y-axis kind of being the horizontal center, now we're going to have a horizontal center at x equals a, okay? So x equals a will be that boundary there, and we'll talk about what that boundary is called here in a little bit. But it's the same graph, right? If n is an odd value, then you'll get this positive on the right and negative on the left, right? So it goes towards positive infinity on the right, negative infinity on the left, if this is odd, okay? If this is an even integer, if the exponent is even there, then you'll go up on both sides, right? Positive on the right and positive on the left, okay? So notice how it's, once again, whatever that a is going to be a horizontal shift to that, to whatever a is, okay? And it's always the opposite. So if it's minus a, it's going to go right. If it's plus a, it's going to go left, because everything that happens inside is backwards, if you remember that from Algebra 2, talking about transformations and things. All right, so that's a graphical representation of what we just talked about. So remember that if n is an even positive integer, that means the limits are both going to approach positive infinity. So the limit as x approaches a of that would be positive infinity, right? The two-sided limit would exist, and it would be infinity because it's infinity from both sides. If we did it with this one, remember that's when the limit does not exist, because it goes different directions on both sides. So the limit here, as x approaches a, the two-sided limit would be does not exist. Okay.